Today, we're going to tackle a foundational puzzle that might just completely change how you think about scientific truth. It's an idea that gets right to the very heart of how we think we know what we know.
So it all kicks off with the question that sounds super simple, almost like a kid would ask it. How do scientists actually prove that a law of nature is true? I don't mean just for here and now, but everywhere and for all time.
Well, the common sense answer, the one we all kind of grow up with, is that science works by just observing specific examples. We call them singular statements, right? You see a white swan, then you see another one and another one. And from all these individual sightings, you create a general rule, a universal statement. All swans are white.
Now, this process actually has a name. It's called inductive inference. And for centuries, this was seen as the way science worked. You observe, you generalize, and boom, you've got a law. Sounds simple enough, right? Well, turns out it's not nearly that simple. See, this whole seemingly straightforward idea runs smack into a massive logical roadblock. It's a really deep philosophical problem that was first laid out crystal clear by the brilliant philosopher David Hume. And this right here is the heart of the problem. It doesn't matter how many white swans you've seen. You could have seen 1,000, 1,000,000, even 1,000,000,000 of them. But you can never be logically 100% certain that a black swan doesn't exist somewhere. You just haven't looked yet. That means your universal conclusion could always, in theory, turn out to be flat out wrong. And that is the core of what we now call Hume's problem of induction. The big takeaway is that you just can't logically justify a universal, all-encompassing law based on a limited, finite number of observations. That leap you take from some to all, that's really an act of faith, not an act of logic. Okay, I know what you might be thinking. Wait a minute. Why don't we just create a new rule for logic? Let's call it a principle of induction and just say, hey, this kind of reasoning, from specific to general, is totally valid. It's a clever thought, but unfortunately, it really doesn't work. Because the moment you try to justify that new principle, you walk right into a classic philosophical nightmare. It's called the infinite regress trap. So here's how this trap springs on you. To justify your theory about swans, you use your new principle of induction, okay? But then, how do you justify the principle itself? Well, you'd have to say something like, it's worked in the past. But hold on. That argument is itself an induction. So to justify that, you need another higher-order principle, which would also need to be justified. And yeah, you're sent down a rabbit hole of justifications that goes on forever. And you can't even get out of this by saying, well, okay, theories are just probably true, because that just creates a principle of probability that falls into the exact same trap. It also needs its own justification, and that starts the whole infinite loop all over again. So we arrive at this honestly kind of startling conclusion. You can never, ever prove a universal scientific law is true just by observing things. You can't verify it. And with that, the whole idea of science as a process of proving things seems to just crumble. But just when it feels like the entire foundation of science is built on sand, a really beautiful and elegant solution pops up. All we have to do is look at the problem from the complete opposite direction. And this table just illustrates it brilliantly. There's this fundamental asymmetry between trying to prove a theory and trying to disprove one. Think about it. To prove all swans are white, you need to observe every single swan that has ever existed or will ever exist. That's impossible. But to disprove it, all you need is one. Just one single black swan. This asymmetry, it's everything. It's the key. While 1,000,000 observations of white swans can't logically prove the theory is true, one single solitary observation of a black swan can logically prove the theory is false. This really powerful insight, which was championed by the philosopher Karl Popper, doesn't destroy science. Not at all. In fact, it gives us a much stronger, more realistic, and way more robust foundation for the entire scientific method. So here's the crucial point. The goal of science isn't actually to prove theories right, it's to try as relentlessly as possible to prove them wrong. Scientists come up with these bold theories, and then they subject them to the most severe tests they can think of, actively looking for that one black swan that could bring the whole thing crashing down. A theory that survives this brutal process isn't proven, no, but it is provisionally accepted. It's the best explanation we've got, for now. So this completely flips how we should be thinking about scientific knowledge. It's not some grand, solid cathedral built out of absolute, unchanging, proven facts. That's a myth. A much better way to think about it is like a ship that we are constantly rebuilding while we're sailing on the open sea. We test every plank, every beam. The ones that fail under stress, we toss them and replace them. The ones that hold strong, we keep. The ship is always getting stronger, always evolving, but it's never really finished.
And that leaves us with one final, pretty provocative thought. Science isn't about collecting permanent facts. It's this humble, dynamic, ongoing quest, which really makes you wonder, right? What cherished ideas, what things we think of as proven today, are just waiting for that one single, unexpected observation to come along and change everything?